Okay, welcome to the first episode of a board Q&A session. As we promised, basically we will answer your question every week, and if you submit your question right at the link below, chances are we're going to pick them and we're going to answer them if it's interesting. So we found a few very interesting questions that we basically received for the past week, and this is one of them. So this first question itself is what we call the pedigree diagram. So what's so special about pedigree diagram is that it shows you the inheritance and pretty much how the genetics, the genotype is being passed on from one generation to another. So the top one is normally starting off from the very first generation of the family, and then it goes down. So there are 3 tiers. So quite simple to understand. So a little takeaway for you. So you got to understand they are talking about blood group. Okay, blood group we have 4 different types of blood groups. So the first one is A. Always remember, blood group A is dominant allele. A on its own is a dominant allele. So when it matches up with IA and IA, that's how we represent the blood group. IA. So when we put them together, so that itself gives us blood group A. So if it's IAIO, that also gives us blood group A because it's dominant. But when we look at blood group O, on the other end, it is a recessive allele. Recessive allele does not, express itself if it's only one, but they only express, when it's both the same type of what we call recessive allele. So blood group O is quite easy to predict. It has to be IOIO. Whereas for blood group AB, quite unique, we call it the codominance. So what's a codominance? Pretty much, when 2 dominant alleles coming together, we can't decide which one to go first. We can't go up. Let's choose blood group A because it's, a better dominant in this case. So we can't really tell that. So when we put these 2 together, we understand that these 2 are both dominant and they stay dominant. So IB and IA, when they come together, they get, blood group AB. Pretty much codominant in this context. So if you look through the entire thing, blood group A and B, they're the same. So the only thing that you need to work out now is basically the let's work out this question from the offspring. That's how I see it. So you see this is blood group O. I believe this is IO. Okay, both the gametes I suppose has to be IOIO, and this one is just IA and I. Okay, we got to decide. Is it IA or IO? I believe it's IAIO. Why is it so? Because you look at the parent. This parent 5, right? So this is O. So I believe if you break it down, if you look at the gamete has to be IOIO. So both of these, the 2 offsprings will have to carry the IOIO. So from what I see, this A is not entirely homozygous A, it's a heterozygous A. Okay, so it's IA and IO. So that's how we work it out. So understanding that, this must be blood group A, right? I mean, how else could you get A? So what would this be? This A, I suppose you can look into, for parent 4, right? You can look into A being IA and IO as well. I mean, you need a 2 combination of O to form O. So that's, a giveaway. So the A has to be a heterozygous A. So now let's work backwards because the idea is not to get parent 4 and 5, but to get parent 2. So in this very context itself, knowing that there's IA and IO, so let's just use a different color so that you can see very clearly. So this IO is pretty much there. So I believe to a certain degree, this must have IO as well. This must be IB. Why is it so? So if you look at the possible combination that this can come up with. So this is IA, let's just say IA. So you need this to be IA and IO. So this, this could be both types. It could be both types, IA, IO. Or it could be just homozygous, but regardless, the combination come together. You notice that yes, the only possible combination that can give you IAIO for parent 4 is when the parent 2, in this case offspring 4, is that the parent 2 will have to be IB and IO to obtain that particular combination. So it's quite unique. Okay, it's quite unique. It seems like, this is B, right? So if this is B, I think the best way to keep it is to keep it a heterozygous. So this is your combination and this is your combination. So if you cross it, you notice that that is the combination of allele that you will obtain. Quite fair, very direct. And the second question that we receive, okay, this is again genotype. So they said, which parent could produce offspring with blood group O? With explanation, please. Wow. Which parents could produce offspring with blood group O? Okay, this has to be Punnett square. Heterozygous means two of the alleles are different. Homozygous means two of the alleles are the same. So they said, so to get blood group O, you got to understand Punnett square has to be in place, okay? And understanding that blood group, the allele, okay, the type O blood group, it is a recessive gene. So we need to obtain two of the same thing. So they show you heterozygous, which parent could produce offspring with blood group O? Heterozygous father with blood group A and heterozygous mother with blood group B. So in this case, okay, heterozygous father, blood group A. So IA, IO. The other one, heterozygous mother, IB, IO. So if you do the combination, you get IB, IA, IB, IB, IO, IA, IO, and IO, IO. Okay, looks good. Looks like that's a what we call, that's a homozygous, okay, R. So this is blood group R. So that's a possibility. So heterozygous father, blood group A, and homozygous blood group B. Impossible. That is impossible because you need to have both blood group O's coming together. The other one, homozygous, technically in this case, looking at it, in order to get recessive, it is either, both the parents contain O, else they will have to be both heterozygous to have the possibility of getting IO. So this, okay, it seems like A is the answer on its own. So quite okay. Quite a friendly question. So let's look at question 3. Alright, let's look at the third one. So basically it says, find the highest common factor of 90 and 48. So this type of question I suppose is quite straightforward. So to find the highest common factor, so between 48 and 90, I would definitely suggest you to bring it down to its simplest, what we call the, find out all the prime factors and try to divide both numbers and try to bring it to the lowest point. So the best way to do it right now, let's just say, from what I see a common, multiple between these two numbers. I believe it's 3. So if you divide it, so you get 16 on one side for the 48, and then you get 30 for 9. Yeah, you take 90 divided by 3, you get 30. So super simple. And then I think you can continue on. I think you can still keep going. So you just have to divide it by 2. So if you divide it by 2, this gets to 8, and this goes 15. So technically this is already the place where you could no longer divide it with a common multiple. So the best way to do it now is very simple. Just multiply the side. This is the rule. So you divide until you can't divide no more. So until you can't divide no more. Okay, so this itself gives you what we call the HCF. You take 3 times 2, your answer is 6. So that's how simple it is. Okay, for this chemistry question, so the third question for this one, it says, when blue-green crystals of nickel 2 sulfate are heated, water is produced and a yellow solid remains. When the water is added to yellow solid, the blue-green color returns. So it seems like this entire process is reversible. Why is it so? Because it was initially blue-green. When you do and conduct a reaction on it, it turns into yellow solid and water is produced. But when you reverse it, when water is added back into the yellow solid, it goes back to blue-green. So this entire process, as simple as it gets, it is a reversible reaction. But of course, just for your extra information, reversible reaction can happen to any kind of reaction that can be reversed from reactants to products, and from products back to reactant. So it goes both ways. So, another example that are very famous in what we call IGCSE is that they give you this hydrated copper or cobalt 2 chloride. Let's just say hydrated cobalt 2 chloride. So initially, let's just say it begins with an anhydrous version of cobalt 2 chloride. So that itself is blue color. So when you add water to it to turn it into hydrated, it turns into a pink color product. So if you remove the water again, it goes back to blue. So this entire process, reversible reaction. Okay, combustion requires oxygen. It gives you a different product. More than often, it gives you, if you burn fuel, carbon dioxide and water, those are the two products you expect. Corrosion, neutralization, trust me, those are not the ones. So, for this question, okay, reversible reaction it is. Okay, now this is an interesting question, mathematics. What is the upper bound of B? So they said A correct to the nearest whole number, H correct to the nearest whole number. So they give you these four. Okay, so it looks quite friendly. So if you write down the question, okay, this is the question, right? Okay, now they want it to be an upper bound. Okay, an upper bound for the value of B. So the idea is to make B the subject. So in this case, I believe that's 2A over H equals to B, right? So if you just move this 2 to the other side, you multiply it, and then you move the H, you divide it. So you end up getting 2A over H, okay? That's B, okay? That is B. So you need this to be what? You need this to be upper bound. Now that's very interesting. In order to obtain upper bound, okay, you gotta have, first of all, this is upper bound. Why? Because it's numerator. If it's an upper bound, it gives you a larger figure. So it's more like a directly proportionate relationship, but it's not really that thing. Yeah, but just numerator thing, right? If the top number larger, the overall answer larger. And then it's divided by H. So the idea is that the H, should I use an upper bound or should I use a lower bound? If you use an upper bound for H, it's going to be a larger number in the denominator. So you divide it, you get a smaller number. That's not what you want, because you want to obtain a the higher upper bound of B, so a higher value of B. So you got to divide a smaller number of H as in this case a denominator. So you need this lower bound to be, you need this denominator to be lower bound. So that's the trick. So to understand the nature of the arrangement of equation, that allows you to determine whether it is an upper bound or lower bound. So now they gave you the figure. A is 10, H is 4. So they are both to the nearest whole number. So how do you do upper bound, lower bound? The idea, super simple. Upper bound, lower bound, you take whole number, right? They say nearest whole number. Okay, if it's nearest whole number, I believe it is 1. So in order to make an upper and lower bound, I'll divide the nearest whatever that is by 2. Okay, divided by 2. So in this case, you have 0.5. So you can choose to plus 0.5 or minus 0.5, plus 0.5 or minus 0.5 according to the bound, the upper bound or lower bound that you want to find. So if you want to find upper bound for A, which we have already decided, yes, we just have to plus 0.5. So it's 10.5. If we want to find lower bound for H, we just have to minus it by 0.5. We get 3.5. In this case, 2 times 10.5 over 3.5. That's your answer for B. Okay, that's your answer for B. You get 21 over 3.5. So 21 over 3.5 gives you what we call okay, it gives you 6. So that is the answer. Okay, all right. So if you have any other questions to ask from this video, or you have any other doubts that you want us to solve, you can always comment down below, share it with your friends, or you can actually always head down to boardedu.org to ask more questions. So just as usual, we will always answer and select the 5 most interesting questions that are asked on board, and we will make a video like this for you next week. So my name is Andy, and I hope to see you guys in the next video.